behind the scenes, remotely sensed data plays a critical role in a smart GIS. Feeds the living atlas, it brings apps to life, and it advances understanding. Remote sensing is changing the way we see the world. Global satellites collecting imagery that help us understand vegetation, urban development, water resources, and climate change. Imagery that's being transformed using GIS into products that guide decisions, land cover change and storm warnings, products that capture the past and anticipate the future, constantly gaining precision, moving from the global to the local. Remote sensing is changing. Timely airborne imagery, information-rich LiDAR, enabling new kinds of products, both 2D and 3D. And now drones in the hands of every organization. Remote sensing is getting personal. Individuals are collecting data. Every phone is a sensor, continuously imaging and monitoring our world. Remote sensing is everywhere. All around us is a connected, dynamic world of sensors, an ever-present Internet of Things. Remote sensing isn't what it used to be, and GIS is integrating everything: satellites, drones, people, and infrastructure itself, empowering understanding and enabling a smarter world. Now, to give us a closer look at imagery in ArcGIS, please welcome Peter Becker.
Thank you, Lauren. I'd like to take you on a short tour of image management, new analysis tools, and the processing of drone imagery. Let's first look at managing and serving massive volumes of remote sensing data. In this web app, we're looking at the North Pole in the polar stereographic projection. These Arctic Landsat image service provide access to over 350 terabytes of imagery stored in the Amazon cloud and served using ArcGIS Server. Here, we have pan-sharpened imagery of Greenland's Tracy Glacier. Also accessible are the multispectral imagery, with all the processing being performed on the fly. These services are updated daily, and we can look through and see, for this area, the latest seen is from the 5th of June, and we can go back in time to 1995. These services also provide, or rather this app also provides access to 2-meter resolution Arctic elevation models created by the Polar Geospatial Center based on the processing of tens of thousands of high-resolution stereo scenes. As the service is temporal, we can request the server return a profile to see how ice is changing over time. By selecting 2 dates, we can dynamically return a difference image and compute the change in volume. These high-resolution Arctic elevation models are being incrementally released over the next year. With these new services and apps, you can study and communicate the effects of climate change. Next, let's have a look at some of the new analytical capabilities in ArcGIS Pro 1.3 for image segmentation and classification. Here, we're looking at an impervious surface product for New Orleans, created from NAPE imagery, accessible through ArcGIS Online, and processed using this classification wizard, which guides you through each of the steps. First, you define the inputs, such as the classification method and the schema to use. A segmented image is returned, and we can use the training sample manager to interactively collect new training areas. A preview of the classification is returned, and we can step through to the accuracy assessment. Then, utilize the reclassifier to interactively refine the results. These classification tools are just some of the advanced image processing and analysis capabilities available to you now. Now, let's look at drone imagery. This orthomosaic was created from imagery that we collected over the LA Coliseum using this 3DR drone. Last week, the FAA introduced rules for the use of such small drones, creating new opportunities for business and governments to use them. Drone to Map is a new app for the integration of drones into the enterprise to create mapping products and inspection workflows. In the field, we use the rapid mode to create a new project and added the imagery. Immediately, we got an overview of the project and could review the imagery. Ground control was added to improve the accuracy. On returning to the office, we've processed the remaining 2D and 3D steps, and by the end of the day had created this orthomosaic, the corresponding digital surface model, and this 3D scene that will be used by USC for the planning of events for this landmark Coliseum. These products can be shared, making them accessible in your WebGIS. So as you can see, ArcGIS is your platform for managing, serving, analyzing, and using imagery. Thank you.